Hey guys, so today is Wednesday, April 8th. So the goal today is going to be now to start to make connections between factoring quadratics and graphing quadratics. And there are many ways that we can represent quadratics, but today we're going to focus on graphing and factoring. And we're going to solve quadratics in these two ways. So example A, we're going to review how to graph a quadratic function in vertex form. So as a reminder guys, here's your vertex form from before. Remember, we're good at this, A, H, and K. So let's start with that. Example A, if I want to identify A, H, and K, first off, this is vertex form. So I can write that in my description here. Notice how here A equals to -1. So if you recall from that before, when A is -1, at that moment, I know I'm going to have a frown face as far as the shape goes. It's going to be concave down, and I'm going to have a maximum point, which will be, if you think about it, on a frown right there. So that one value gives me all that information. I can then find H and K. So here's H and K. Remember that H and K is your vertex. So your vertex here is going to be, H is going to be 1 and K is 4. Recall that when you identify H, it's the opposite of what you're seeing because the negative is part of the actual formula. So the vertex is 1, 4. So I'll go ahead and put it here on vertex. It's 1, 4. And the moment you have that for your parabola, you now have your axis of symmetry, which is at x equals to 1. It'll always be the x coordinate of your vertex. If I plot this one point here on my graph, it's the point 1, 4, so it's going to be right here. And again, that's my axis of symmetry, so I have that there as well, my mirror. And then all I have to do at this point is generate the rest of my graph. So knowing that my a value is -1, we learned before that basically if I put my vertex on the table, I can apply the a value as a slope, if you will, of the next point over. So if I just, in this case, subtract 1 to 4, I get 3. So at the point 2, I'm going to have a point 3 as well. And I can reflect that point. So there's my U shape taking form. To finish, I can find an additional point by finding, say, the input of 3. So if I just input 3 into my original equation, so negative parentheses x minus 1 squared plus 4, but I'm going to input a 3 into where x used to be, so there's my input of 3. I can work this out. 3 minus 1 is 2, so I have 2 squared, and I have all the other components still in the problem. Next, 2 squared is 4, the minus sign drops down, and then 4 minus 4 is 0. So when I input a 3, I output a 0. When I input a 3, I output a 0. So that's the point 3, 0, which will be here. And I can reflect that point also. Notice how at that moment I have my parabola. So there's my parabola. I kind of missed, but you get the point. Now, when I solve this graphically, what that means is, like we've done the last couple of days, wherever your graph crosses the x-axis are your solutions. We may also call them x-intercepts or roots. So in this case, it's at -1 and +3. So if I want to solve graphically here, I can say it's going to be -1 and +3. These would be my solutions to this quadratic equation above in vertex form. So with that, guys, go ahead and pause the video. Please try again to review graphing. Try graphing example B and try to find out what your solutions would be to B's equation. Alright guys, so here's example B. I kind of worked out most of it for you. So notice how here's my original quadratic equation, or function in this case. I went through and I graphed all of it for you. And when I graphed this parabola, notice how A is a +2, so it is smiling. But if I ask you to solve this graphically, my solutions are going to be where the graph crosses the x-axis. So here, it would be at x is -4 and -2. Those are my solutions, or my x-intercepts, or my roots, or my zeros. All words apply there for that. So my solution would be x is -4 and -2. I've now solved this quadratic function or equation graphically. Okay, so with that, that's kind of the note for today. So the rest of the assignment is going to be just practicing factoring and solving and checking graphically, make sure that all these things connect and make sense together. So example C, and again like yesterday guys, let's use Desmos as we work things out factoring wise. Once we factored and gotten our solutions, check the graph, make sure that it connects and it fits. So example C, we'll do it together. In this case, if I follow my steps from before, the first thing is this in standard form? Yes, it is, because it's equal to 0. Next, is there a GCF in this equation? And there is one in this case. I can divide them all by 2. So if I divide by 2, I end up with x squared plus 7x plus 12 equals 0. And this will help me to keep my work a little bit easier, because this GCF I can kind of ignore in my work and bring it back at the end in the answer. So at this point, I can identify A is 1, B is 7, and C is 12. So I'm going to go ahead and try to factor this directly. So A times C here is 1 times 12 is 12. That goes on the top of the x. And my B number is 7. Making a list of factors of 12, it's 1 times 12, 2 times 6, and 3 times 4. Notice how 3 and 4 can make 7 in some combination, so I'm going to use those numbers in my x factor. And it happens to work this way now. So again, the purpose of the x factor is to take the quadratic that I'm using. So in this case, it's x squared plus 7x plus 12. So it's what's here in the parentheses. This is what I'm factoring currently. And I can split this bx term into two terms, now using the 3x that I found and the 4 that I found, which will allow me to then factor by grouping these 4 terms into 2 pairs of 2. So here's my first group, my second group. As I factor out the GCF here a couple of times, going faster now because it's the same process we've done for a few weeks now. Notice how I can factor out an x and then a 4. And as always, guys, we expect in this process that as we factor, these need to be the same. So I feel good about that. To finish, I get x plus 3 as one factor, and then x plus 4 as the other, and this is equal to 0 still. This is the point where whatever GCF was in the beginning should reappear in the answer here. So this is called factored form, where x plus 3 is a factor, x plus 4 is a factor, and then in this case I have a GCF also. To solve this quadratic that's in factored form, I'll take each factor, so x plus 3, and I'll set it equal to 0. And I'll take the other factor, x plus 4, and set it equal to 0. Again, this will give me my solutions as I solve each of these little equations on the side. So minus 3 on this one, and I find that x equals to negative 3. That's one solution. And then I can subtract 4 on this other little equation, find that x is negative 4. So I just found my solutions to this quadratic equation. Now, if I go on Desmos, and please guys do this for all these questions, and here's a picture of the Desmos I did before. Notice how I typed in the original quadratic without the equal 0 part, and I got a picture. My hope is that my picture will match. And guys, I just noticed something. I made a mistake here. Look at the answers that I got. These don't match my picture, but look at what I did here, guys. My fault. I wrote the wrong question. I put plus 4 instead of plus 24. So let me pause for a second and fix it for you. Alright guys, sorry about that. So I fixed the Desmos graph. So here is the graph of the actual question we have. And notice how if I check my answers that I've computed, I get x is negative 3 and negative 4. And here you can see x is negative 3 and negative 4. So my answer does match my graph. So for the rest of the assignment, guys, please pause the video, try these. This is just like another example of factoring and graphing. Make sure that the graphs and the factors, the answer you get from factoring match, and just get better. As you do more, guys, you get better at this, okay? So pause the video, please try the next 5 examples and check in, and I'll show you one by one at that point. Alright guys, so here's example D. So again, just going through each point quickly, I found the discriminant. It's a perfect square. I went through my x factor, went through my factor by grouping, found my factors again, and then I found my solutions. So the point is to check my solutions through Desmos and see if they match. So I found that here x is negative 5 and positive 9. So if you look at the actual graph, here's negative 5, and then here's positive 9. So again, I can verify my work through Desmos if I type in my original expression and just check the picture. Again, pause and try E, please. Alright guys, so example E. So in this case, notice that before I did any work, I noticed that this was a difference of 2 squares. So in this case, I can avoid all the work because 4x squared is just 2x times 2x, and 1 is 1 times 1. So I can go from the original question to factored form immediately using that shortcut. So here I have my 2 factors. When I solve each factor setting it equal to 0, I can find my 2 solutions to be half and negative half. And go on Desmos and please type in this expression and verify that your parabola has the same x-intercepts which you found for your solutions. Alright guys, so here's example F. So again, looking at this in steps, I first found the discriminant up here to be 81, so that's a perfect square, so I can continue. Then there was a GCF here that I took out. Actually, I did that first. Going through my process, again, pause this and kind of work through the steps, see if you follow what I did. I used colors for you. All the way down to getting to factored form. So my GCF was 3. Then we have 2 factors here. Then to solve, I took each factor, set it equal to 0, and solved each one to find my 2 solutions. Here, x equals half and 5. Again, they're also called roots and intercepts and zeros. So go into Desmos, type in the original expression and make sure that your graph crosses at these same 2 values. And pause and please try G. Okay, so actually in this case I'm going to show you G because G and H are a little bit different. If you look at G and H carefully, notice how these are not equal to 0, both of them. So these are not in standard form. So in these questions, before I do anything else, my first job will be to make them standard form. And all I have to do is move this constant to the left. So in example G, to move this 4 to the left, I'll just subtract 4 to both sides, because 4 minus 4 is 0, so this becomes 0, which is what I need. Then I have x squared minus 5x minus, in this case, 24. So at this point now, I can go through my familiar process of factoring the exact same way I've been doing this whole time. So I can make the x factor, and I'll go a little faster, so minus 24, and then b is minus 5. And then as far as 24, isn't it 3 times 8? Again, I'm going to go a little faster here just for speed's sake. So I'm going to choose those factors to insert here and make the negative. At that point, I can take my x squared minus 5x, my original standard form question that I just found, and I can now rewrite the middle term as plus 3x minus 8x. Again, I'm pulling those from the x factor here that I just found. The front and the back stay the same. I'm going to factor by grouping, like we've done on for about a week. So I'm going to go a little faster, if you don't mind. Hopefully this is okay with you. So let's have a negative 8 in common. So x plus 3. And so I end up getting x plus 3 as one factor, then x minus 8 as my other factor. And that's set equal to 0. So now that I have my factors to find my solutions, I'll just take each one. X plus 3, set that equal to 0. And I find that I'm going to have x equals to negative 3 as one solution. And then take the other factor, x minus 8, set that equal to 0. And I can solve that and find that my other solution is x equals to 8. So just like that, I factored and solved this quadratic to find that x is negative 3 and positive 8. Again, on Desmos. And guys, for Desmos, you can type in this expression here. And again, compare what you found algebraically here by factoring to the graph. Make sure that the picture connects to the answers. Okay, one more attempt. Please try H and then come back and I'll show you the answer. Alright guys, so here's example H. Again, this was not in standard form. I moved the 5 back to the left with the negative 5. I found my A, B, and C, went through my factoring process, found my factors of x plus 2 and x minus 10, solved them each to find that x is negative 2 and x is 10. Again, one last time, go on Desmos, verify that these answers match the picture that Desmos creates. Alright guys, with that, hopefully that made some sense. Hopefully it's getting better for you. And tomorrow I have some more practice. And you guys have another quiz this Friday on factoring quadratics to solve. Take care, guys.